So in this lecture we'll understand the pressure measurement devices. There is a three types of devices here. There is a barometer, manometer, mechanical gauge. So there is a types of devices. That is, first there is a barometer, and second that is manometer, and third mechanical gauge. So barometer will be like this. So there is a mercury, and there is a small diameter tube which is inserted on the mercury, and this is the height. Okay, and here there is a P that is equal to 0. So vapor pressure is very less at that region. So mercury is used for the barometer. Okay, and high density fluid. So mercury is the high density fluid and very low vapor pressure. So due to that we use the mercury in the barometer. So P atmosphere, that is equal to rho into G into H. Okay, so there is a manometer and mechanical gauge. There are four types of mechanical gauge. One is Bourdon tube pressure gauge, second diaphragm pressure gauge, third bellows pressure gauge, and fourth dead weight pressure gauge. Now we'll understand the manometer. Okay, so manometer. So manometer, it is a pressure measurement. So pressure measurement is defined by liquid column deflection. So manometer are basically two types. That is a simple manometer, that is measure pressure at a point. So this simple manometer is measure the pressure of a point, and there is a second, that is the differential manometer. So simple manometer are three types, that is piezometer, U-tube manometer, single column manometer. So piezometer, for piezometer the total head P by rho G plus Z plus V square by 2G, and the piezometric head P by rho G plus Z. So this is known as piezometric head. So piezometric head P by omega, that is rho G, P by omega plus Z, this is the piezometric head, and total head P by omega plus Z plus V square by 2G. Okay, and differential manometer are three types, that is U-tube differential manometer not depends upon the orientation. So this U-tube differential manometer does not depends on the orientation, and second, that is inverted U-tube manometer, and third micro manometer. Okay, so now we will focus on the piezometer. So what is a piezometer? Piezometer measure the pressure at a point. Okay, so it is the simplest form of manometer whose one end is open to atmosphere and other end are connected where the pressure is measured. Pressure is to measure. So it measure the gauge head. Okay, so consider this is the point here. So you have to measure the pressure of that point. Okay, so there is a liquid column deflection is there. So here the manometer whose one end is open to atmosphere. So here there is one end open to atmosphere and other end is connected where the pressure is measured. Okay, so here this distance, so here to here the distance is H, that is P by omega, and from here to here the distance is Z. So if you want to measure using this tube, so suppose the size of the tube is like this. So here also H, that is equal to P by omega, and Z, so this is the Z. Okay, and for that case here, so if the tube is like this, so here this is Z, height Z, and from here Z to this height, that is H, that is P by omega. So, and this is the line, this is the reference line. Okay, so this is the reference line, and here there is a P atmospheric pressure. So here there is atmospheric pressure, here this is the atmospheric pressure. Okay, but the problem is that so piezometer cannot measure the gaseous pressure. So the disadvantage is that so it cannot measure the gaseous pressure, and it cannot measure the pressure less than atmospheric pressure. So this is very, very important. It cannot measure the pressure less than the atmospheric pressure. Okay, so it is difficult to measure high pressure of low density fluid. due to large liquid column deflection. So if we want to measure the fluid which have a high pressure but low density, so for that case there is a large liquid column deflection. So this is difficult to measure that pressure because the liquid column deflection is more for that case. So note that piezometer can be installed in any orientation because the piezometric height P by rho g plus z, that is same over entire cross section in pipe flow. Okay, so this is the reference line here, and there is a point where you have to measure the pressure at the point, and this is the tube here. This is the L-shaped tube. Okay, so the height from this reference to point P, that is Z, and here the liquid column deflection, that is H equal to P by omega. So P, and this is going upward, so this is minus rho gh minus rho gh. So this is the P, that is equal to H into omega, that is equal to rho g. So P equal to rho gh, that is equal to, here there is atmospheric pressure. So P minus upside is minus, so upside direction is minus, so P minus rho gh, because P here minus rho gh, that is equal to P atmosphere. So absolute pressure, so from here P equal to P atmosphere plus rho gh. So P here is the absolute pressure. Okay, so this is the absolute pressure. Now if the atmospheric pressure is 0, then it is known as gauge pressure. So what will be the gauge pressure? That is rho into g into h. Rho g we know that omega, that is omega into h. Okay, so now let's try to understand this case. So this is the reference line here, this is the reference line here, and there is a fluid, that is a fluid, and here there is a piezometric tube. Okay, so here the distance from the reference line to this height, that is z, and here the height, that is P by omega. Okay, so if you install one pitot tube, so here this is the stagnation point is there, so V equal to 0, and for that there is a V square by 2g liquid column deflection, there is extra liquid column deflection are there due to the stagnation. So here this is the distance, that is P by omega, that is equal to h, and here the extra liquid column deflection are there, consider this is h, that is equal to V square by 2g. So here this V square by 2g, that is equal to h, you can say that because here h, that is equal to V square by 2g, so V equal to under root 2gh. So from here you can calculate the velocity at that location, so that is equal to under root 2gh. Okay, let's try to understand this question, important question. So in given figure, if the pressure of the gas in bulb A is 50 cm Hg vacuum and P atmospheric pressure, that is 76 cm Hg, then the height of liquid column H is equal to, so you have to calculate the height of liquid column from this point. Okay, so this is the mercury level. Okay, and atmospheric pressure is also given, and the pressure of gas in the bulb A, so here the pressure is, vacuum pressure is given 50 cm Hg. So how to calculate that? You have to calculate the height of the column, mercury column deflection. Okay, so here consider this is one point and this is another point. So absolute pressure of 1, that is equal to absolute pressure of 2. So for 1, what will be the absolute pressure? That is atmospheric pressure, and there is no gauge pressure. So for 2, that is P atmospheric pressure minus there is a vacuum pressure, and there is a positive pressure, that is rho gh. Okay, so from here H, that is equal to H of vacuum pressure, that is equal to 50 cm of Hg. This is given in this question. So this is 50 cm of Hg. So this will be our answer. So this is my handwritten notes. You can download it from the description, The link is available on the description. Thank you.